Hi Year 8, I hope you're all well and having a good week. I'm looking forward to doing some maths. Today we are going to be doing probability trees for independent events. So if you want to put a date and title in your book, just pause the video quickly now. Okay, so we're going to go through a few examples together. What I'm going to suggest to you that you do is the first example goes in your yellow notebook in the probability section, and then I wouldn't worry about having more than one example in there. I would do the second and third ones, have a go at in your exercise book, but if you really want to put the other examples in your notes book, that's up to you. Okay, so the first example is this. You might want to pause the video just to write those couple of sentences in. A box contains 7 red and 3 yellow pens. A pen is selected at random, the colour noted, and then returned to the box. A second pen is then selected at random. What is the probability of picking 2 red pens? So what we're going to have to do with this is put together a couple of the things we've already learned about probability and sort of 1 or 2 new bits. Now you are going to be you are going to be using probability trees to solve these problems. For today's lesson, I'm going to give you a sheet where the trees are already drawn for you. I want you to worry too much about drawing the trees from scratch. We might look at that later down the line. But I'm going to show you me drawing this tree for this one, which you're going to copy in, and as ever, pause the video as much as you need to, and so I can just talk you through what's happening. So there are 2 events here. The first pen is being picked out, and the second pen is being picked out. And those 2 events are independent of each other. They're 2 completely separate events. Now, for the first pen, there are 2 possibilities that could be the outcome. So my tree, or my part of my tree here needs to have 2 branches. Oh, let's just extend that on slightly. And my 2 possibilities for my first pen are red and yellow. So my 2 possible outcomes go there. On my branches needs to be the probability of each of those outcomes. So the probability of red, well, how many things are there that I want? There is 7 red things that I want. Out of how many things are there all together? Well, there are 10 things all together. Another rule that we've sort of touched on, but not explicitly so far, is if there's a random event happening, like picking pens out of a bag or spinning a spinner or rolling a dice, all of the possibilities have to add up to 1, because it's certain that one of them will happen, and so all together the probability needs to add up to 1. So there are a couple of ways we could look at this. We could look and say, well, there are 3 yellows out of 10 altogether. The other thing we can look at is if the probability of this is 7 tens, this and this need to add up to make a whole, so that would have to leave me with 3/10 here. Then there's the second outcome, which I've just realised I've not set it up beautifully, but we'll have to make it work. The second pen. Again, there are 2 possibilities for the second pen. I'm going to just do it slightly skinnier. The second pen could be red or yellow. But I need double branches here, because if the first pen is red, then the second pen could be red or yellow. But if the first pen is yellow, the second pen could still be red or yellow. And again, the pen is put back in the box. The first one is put back in the box. So the probability of getting red is still 7/10, and the probability of getting yellow is still 3/10. And here, again, the probability of getting red is still 7/10. And the probability of getting yellow is still 3/10. We want the probability of getting 2 red pens. Well, the probability of getting 2 red pens, well, my first pen would have to be red, and then my second pen would have to be red. So the only way I can get 2 red pens is if I go down the red branches. So it's only this bit here that gives me the probability of getting red. And the sort of new rule for today is that if I've got 2 independent events and I've got want the probability of them both happening, this one and this one, I have to multiply those probabilities together. So the probability of them being both red is going to be 7/10 for the first red times 7/10 for the second red. Now do feel free to use a calculator when you're doing these today, but hopefully you can remember from times in fractions, times across the top and times across the bottom. So it's 49 hundredths is the probability of them being both red. Pause the video now if you need to just make sure you've got that all in, and we'll go through a couple of examples together. Bob and Rex sit an exam. The probability that Bob passes is 0.35. The probability that Rex passes is 0.6. What is the probability that neither pass the exam? So again, there are two possibilities. Again, don't worry too much about drawing the trees. The ones you're going to do today, the trees are already drawn for you. Okay. The first thing that's happening is Bob's exam. And there are two options for Bob. He can either have pass or not pass. And then the second thing that's happening is Rex's exam. And Rex's exam is going to happen, doesn't matter whether Bob passes or whether Bob doesn't pass, sorry. Rex's exam is still going to happen. So, the probability that Bob passes is 0.35. And remember, these two things, one of these two things has to happen. So all together, it has to add up to 1. So if this is 0.35, that makes this is going to be 0.65. And then we've got Rex's exam. Again, whether Bob passes or not, Rex's exam could be a pass or a not pass if Bob passes. And if Bob doesn't pass, Rex's exam still could be a pass or not pass. And the questions told us that the probability that Rex passes is 0.6. So Rex passing here must be 0.6. And Rex passing here must be 0.6. And we know that Rex passing or not passing has to add up to a whole. It's certain that he's going to pass or not pass. It's certain that one of them is going to happen. So it has to add up to a whole. So it's going to be 0.4 here and 0.4 here to make those add up to a whole. We want the probability here that neither of them pass the exam. Well, that means if I start here, we're going to need Bob to not pass and Rex to not pass. That's the only way. None of these may neither pass. This one they both pass. This one of them passes. This one of them passes. We want the probability they both don't pass. So we're going to need to do both don't pass. So we're going to need to do 0.65 times 0.4. And again, we could work that out with written method using 4 times 65 and putting the decimal places back in. But I'm happy for you to just type it in a calculator. My calculator is just off screen, but I've put it in and it's told me that it's 0.26 is the probability that they both don't pass. Okay, last example for the video today. A bag contains 4 silver and 6 gold coins. A coin is taken and then put back in, and then a second coin is taken. So again, we've got the first coin and the second coin. The first coin could be either silver or gold, and the probability of it being silver, well, in fact, I'll tell you what I'm going to do. I'm going to draw the tree diagram, sorry. Just put S and G there. Pause the video for 2 minutes. Can you fill out the rest of that tree diagram? So 2 minutes, pause the video, copy the tree diagram down. Can you fill the rest of it out? Okay, so hopefully you've done that now. The probability of silver, well, there are 4 silver coins out of 10 coins altogether. So the probability is 4/10. The probability of gold, well, there are 6 gold coins out of 10 altogether. So it's 6/10. And again, this has to add up to a whole. And the coin gets put back in. So it's still going to be 4/10 and 6/10 here, and 4/10 and 6/10 here. The probability of picking 2 silver coins, well, for 2, if I start in here, I need the first one to be silver and the second one to be silver. That's the only way I can get 2 silver coins is there. So probability of both silver is going to be 4/10 times 4/10, which is going to be 16/100. And the probability of picking 1 coin of each colour. This is the last little slightly different bit that might come up today. 1 coin of each colour. Well, there are 2 ways I can get 1 coin of each colour. I can get silver and gold, or I can get gold and silver. So the probability of silver and gold is 4/10 times 6/10, which is 24/100. The probability of gold and then silver is 6/10 times 4/10, which again for this one is 24/100. So the probability of getting 1 of each, well, I can have it either way to get 1 of each. I can have it either of these 2 ways. So the probability of getting 1 of each is going to be 24/100 plus the other 24/100, which is 48/100. There's a couple of questions like that today, but don't worry too much if you're not enjoying those adding it together. The main bit is that you can write the probability on the trees and then multiply down the branches to find the outcomes. Hope you're getting on okay with that sheet. Do let me know if there are any problems, and I will speak to you tomorrow. Have a lovely day.